So in this video, we are going to look at something very important just before we go into the examples for the different types of proofs that we covered. And this is understanding the different types of numbers, because when you're going to be proving a statement, as we covered in the previous video, we need to know certain phrases. And these are phrases that you're going to come across. So to know the different types of numbers, we want to start off by understanding this diagram, because this diagram is going to classify any type of number into their circles. Now, if we look at this diagram, it looks like a Venn diagram. And if we know a Venn diagram, it's when you have circles inside, and they could either be overlapping or they don't overlap. So currently, in this type of Venn diagram, we can see that our circles don't overlap. So that means that within each circle, our numbers are going to be classified into groups, but we can see that within one circle, there are circles within. So that means we are going to have a group of numbers, but within that number, there are different types. So let's first of all start off with real numbers. So real numbers basically means that any number is going to be a real number. So a real number is basically, as in a Venn diagram, the set of all elements. So any number you can think of is going to be called a real number. There's no such thing as a number that is fake. But as we now want to dive further into all of the real numbers, we can see that we can divide them into two main types: irrational and irrational. So you can think of it logically as well, because something that is rational, something that is kind of, firm, it's firm, it makes sense. When something is irrational, it's kind of all over the place, and it's confusing. So we can see with irrational numbers, you're going to have surds. Now, the reason why we have surds is because if you was to try and work out its exact value, the exact value is not going to be clearly known. So that's why we keep numbers inside of a square root that are not a square number as a surd. And also we'd have symbols like pi. We know pi is equal to 3.142. So any number where if you want to know the exact number, it's going to be a very continuous number. It doesn't end. It's going to be irrational. And as we said, something that is irrational is something that is just confuses. The fact you have a number that doesn't end, yeah, it is going to be confusing. So therefore, we call these irrational. Now, the opposite of irrational is a rational number. So rational numbers are numbers that we can make sense. We know the accurate number. We know its final value or exact value. So, for example, we know a fraction, a decimal. Now, of course, with decimals, you can see a decimal can be recurring because there are different types of decimals. So if a decimal is recurring, this is irrational because we can see after the decimal point, the numbers are repeating itself. So we know what type of this number. Whereas when you have a decimal and you have so many different numbers, we don't know when it's going to stop. This is why it's irrational, it's continuous. But we can stop with this number because we know it's going to be 9.4545. Likewise, for example, if you have another recurring decimal, you can have 3.333. The fact we know we're going to have so many threes, we can just say, okay, it's just going to be 3.3 recurring, and that's enough. But also rational numbers, it can be a fraction, and the fractions can be negative or positive. So you can see you have a negative sign for negative 3.4. So these are rational numbers, because all these numbers, you can convert them to one another. So 2/3, as you know, is equal to 0.6. 7/8 is equal to 0.875. 3/4 is equal to 0.75. So you see, these numbers are easy for us to know and understand, which is why they're rational. But as we know, irrational numbers are the opposite. So now integers are a set of numbers that are different to rational numbers. And to know the difference is, integers are basically whole numbers. So integers can never be a fraction. So an integer can be anything that is positive or negative. So positive or negative, but it's going to be a whole number. And there's no fractions. So you can have -5, you can have 10, And it can go both ways. Any whole number from minus infinity to positive infinity. These are going to be integers. Now, within our integers, we can see that we can have whole numbers. So now we can see we are now taking out a group of numbers from each category. So what separates a whole number from an integer is that the whole numbers are positive. So if you have a negative number, a negative whole number is going to be an integer, but any number that is positive, starting from 0, is going to be a whole number. And then now, within our set of whole numbers, we can separate numbers that are natural numbers. So whole numbers is starting from 0 all the way up to a positive integer that is infinity. So it's going to be positive integers. Because sometimes you're going to see some questions where they might say, okay, a positive integer. Then we need to understand that this is a whole number. Now, natural numbers, the only difference between a natural number and a whole number is that the set of natural numbers is starting from 1 and it goes up to infinity. And what we can then finally conclude is that for all of these numbers, as we are going to come across in some questions, is that you're going to see sometimes they don't tell you the words. You have a set notation where they represent rational numbers, real numbers, integers, natural numbers, and whole numbers as a symbol. And I'm going to show you those symbols. So those symbols, we can basically see it below here. So we can see this same diagram is similar to what we had above. In fact, I can probably bring this closer to it. Yep. So we can see irrational numbers. If you see that you have this symbol, a Q with an apostrophe, that means irrational. Irrational means a Q. And the way you're going to see this in questions is that you will say that, okay, N is a set. So this means as a set of, so if you have Q, that means a set of rational numbers. You might have N is a set of, and if you have Z, that means integers. So positive whole numbers and negative whole numbers. If you have a set of whole numbers, and if you see the symbol, N is a set of, for example, N, but it has 0, that's because the natural numbers are positive integers, but it includes a 0. And then if you just have an N by itself, then that means a set of natural numbers, but it doesn't contain a 0. It starts from 1 and it goes all the way up to infinity. So this video is just to allow you to understand the different types of numbers and how they're classified, because when you're going to be looking to proofs, we need to know what these words mean. If we don't know these words, it's going to be hard for us to come up with a statement and then trying to prove that statement according to the type of proof we're using. So I'll see you on the next one, where we're going to be seeing questions where it contains these words and we're going to apply them by knowing the numbers within it.